In this video, we're going to practice graphing tangent and cotangent functions. Now we're going to start by focusing on functions that haven't been shifted horizontally or vertically in this video, and then in the next video we'll graph tangent and cotangent functions with any kind of transformation, including horizontal and vertical shifts. Now, the general way we approach graphing tangent and cotangent, and I'll give you the full general procedure, including horizontal and vertical shifts right now. We talked about this in more detail in the previous video when we went through the textbook. But, okay, we know that tangent and cotangent both have period pi. At least, here you can see the period's been scaled, but just the basic tangent and cotangent functions have period pi. Okay, now we know that tangent and cotangent have vertical asymptotes spaced out pi apart, and with that we can represent a period of tangent and cotangent within two vertical asymptotes. Now, there's no such thing as like a period interval. A period is just the period, right? The period is pi, which means that you go to a point on the graph, and then you add or subtract pi from that, or any constant multiple of pi, and you're on the graph. So there's no period interval, but for sketching purposes, a really good way to look at it is we're going to think about the period is contained between two vertical asymptotes. Okay, and so now if we think about the general definition of the trig functions, so you've got x, y, and then here's an angle measured from standard position. It's convenient to think about like what I'll call the base period of tangent and cotangent. So for like sine and cosine, the definition of sine and cosine, we think about the base period as like going from 0 to 2 pi for either one of those, right? And then if that was shifted horizontally, we thought about that base interval being shifted for the graph. Well, for tangent and cotangent, we can think about, so for tangent, the base period, there's no such thing as that. This is just for sketching. I'm using these terms for sketching purposes. The base period goes from negative 2 pi to 2, or negative pi over 2 to pi over 2, right? So if this was negative pi over 2 and this was pi over 2, that's like I'll call that the base period of tangent. Okay, now of cotangent, the base period is 0 to pi. So if this is 0, and then 1, 2, 3, 4, 1, 2, 3, 4, then this is like the base period. So the sketch would be we have two vertical asymptotes, one at x is equal to 0, and then one here at pi and the sketch the period that we would sketch would be in between those two vertical asymptotes. Okay, and so what we want to do is for each function, we want to sketch the base period and then just copy and paste it all throughout the rest of the graph, like similar to what we did with sine and cosine. So really the first step for any tangent or cotangent graph is identify where the base period is, because it might be shifted horizontally, right? In this video, that won't be the case, but not only shifted horizontally, but it could also have been stretched or shrunk. So here it's not going to be minus pi over 2 to pi over 2 because the period is going to be shrunk down by a factor of 4. But it's not going to, so what's going to happen is instead of being minus pi over 2 to pi over 2, it's going to be, the period's not going to be pi anymore. It's going to be pi over 4. So we're going to go pi over 8 to the left and pi over 8 to the right. You see how it's not shifted, but it's just been scaled. Okay, but if there's a combination of scaling and shifting of the period of like the base period, we're going to identify where it's been changed to, and then put the vertical asymptotes. That's the first step for the sketch. You put the vertical asymptotes of what I'm calling the base period. Okay, now the next thing we're going to do is we're going to divide the in between that period into 4 equally spaced pieces, and we know that at the very center for both tangent and cotangent, it's going to pass through the x-axis. Unless there's been a vertical shift, then we just account for that vertical shift. It's kind of like we've shifted the x-axis. But at the center, it's going to pass through the x-axis. And then at the first, all we're going to do is we're going to evaluate the function at the first quarter point and at the 3/4 point. At the quarter point and the 3/4 point. We're going to plug that value of x into the function. And those points are going to assist us with the shape, because there might be the shape in the sense of there might be scaling about the y-axis. And then also even that combined with the stretching or shrinking of the period, that kind of changes the shape of the curve as well. So we're going to need some guiding points to help us sketch the curve. But then it's going to, we know that the basic shape, so okay, 1, 2, 3, 4, if this is tangent, 1, 2, 3, 4. So the untransformed shape of tangent is like this. Okay, and so we know that, if there's any flipping, horizontal or vertical flipping, we'll know tangent starts off like this, and then cotangent one, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Starts off like this. Now we'll have those guiding points, so it's like we'll be able to tell from the points we plot what if it's like this or whatever. But still, it's good to think about what's the basic starting kind of orientation of tangent and cotangent. Okay, let's get started. So we've got tangent of 4x, which there's been a scaling about the x-axis down by a factor of 4, and that's the only transformation. So if just the standard y is equal to tangent x, again, the total period is pi, and it's like equally spaced about the origin. So from minus pi over 2 to pi over 2 is that kind of base period. But this has been, the period has been scaled down from pi to pi over 4. So equidistant from the origin, that's pi over 8 on each side. So, okay, 1, 2, 3, 4. Let's do 5. So minus pi over 8. 1, 2, 3, 4, 5. Pi over 8. So this is going to go out to okay, 1, 2, 3, 4, 5. Okay, so let's start by drawing the vertical asymptotes at this base period here. Okay. All right. Now we know no matter what the transformations are that are applied, at the center of the period, it's going to go through the x-axis. Or the shifted, if it's been shifted vertically, the shifted x-axis. All right, so now all we want to do is, okay, we know it's going to, this hasn't been flipped or anything about the x or y axis, so it's going to look something like that. But we just want to plug in a point a quarter of the way, like halfway between here and here, halfway between here and here, to guide us on drawing the curve. So let's plug in minus pi over 16 and pi over 16 into this function. So, okay, we want to get y of minus pi over 16 is equal to, that's going to be tangent of 4 divided by 16, so that's minus pi over 4. And then y of pi over 16 is tangent of pi over 4. Well, we know tangent's an odd function, so tangent of minus pi over 16 is going to be equal to minus tangent of pi over 16. but we can still plug them both in. So, okay, tangent of pi over 4 is 1. Okay, so that means tangent of minus pi over 4 is minus 1, right? So, okay, pi over 4 is here. So, okay, we want to do, let's see, we can make, let's do this, 5 to minus 5. All right, tangent pi over 4 is, so here's 1, and then it's odd, so tangent minus pi over 4 is minus 1. And there we go. So now we can use this to help us sketch the curve. Okay, now we just copy and paste this up and down the entire graph. Let's see, we can. And there we go. Okay, here we can see that the just y is equal to tangent x, the basic y is equal to tangent x, has been scaled up about on the x-axis by a factor of 4 and up about the y-axis by a factor of 2. So the period starts at pi and it's been scaled up by 4, so the period is now 4 pi. All right, so we're going from, it's tangent, so it's the basic period we're going to sketch is equidistant on both sides of the origin. So 1, 2, 3. This is going to be minus 2 pi, 1, 2, 3, 4, 5. 2 pi, 1, 2, 3, 4, 5. 4 pi. Okay, now let's draw the vertical asymptotes of the basic period that we're going to draw. Okay, we know it's going to pass through the middle here, and since this is tangent and not flipped, it's going to look something like this. But let's get some points to guide us, because with the combination of the scaling by the x-axis, it kind of shrinks it in the base graph, and the scaling, or no, it would stretch it out. Yeah, it scaled out. So it would stretch it out, and then the vertical scaling would stretch it out too. So we need some guidance on to get the shape right. But we should just be good going from 5 to minus 5. Let's see though. Okay, so we want to do, let's plug in pi. So y of pi is equal to 2 tangent pi over 4. Okay, in the previous problem, we saw tangent of pi over 4 was 1. So this is equal to 2. Okay, so here is pi, and then we're going to do, so that's 1, there's 2. And then it's odd, so like that. Okay, so let's see. Like that. All right. You can see it's been stretched out horizontally and vertically, right? And there we go. Okay, now here we have a cotangent. Very similar process, just some subtle differences in the sense of, so, okay, we're starting with period pi, and here the period has been scaled down by 3, so we went from period pi to period pi over 3. But now with cotangent, it's not going to be like total pi over 3, but equidistant on each side from the origin. It's going to go from the basic period we're going to draw is going from 0, the first vertical asymptote is at 0, all the way out to positive pi over 3. So we'll do this. 1, 2, 3, 4, 5. Well, let's do, so, okay. I want to make the kind of the major tick marks so it's something consistent. So let's do this. 1, 2, 3, 4, 5. Let's do pi over 2. 1, 2, 3, 4, 5. This is pi. Okay, now we should be good again to do okay. So now where is pi over 3? Let's see. Each tick mark is pi over 2 divided by 5 is pi over 10. Each tick mark is pi over 10. So what is pi over 3 divided by pi over 10? 3 1/3. So 3 1/3 tick marks. Okay, 1, 2, 3 1/3. So right there. Okay, and then we've got the origin is the other vertical asymptote. All right. Now, what is 3 1/3 divided by 2? That's 1 2/3. So the graph is going to pass through the origin around here. Okay, now let's see. Pi over 3 divided by 4 is pi over 12. So, okay, we need to get cotangent of 3 times pi over 12. Cotangent of 3 times pi over 12 is cotangent of pi over 4. And then now we're going to need to actually plug in the, so okay, let's see. Pi over 12, 2 pi over 12, 3 pi over 12 is what? Pi over 4. So we need to plug in pi over 4 into the function. So that's going to be cotangent of 3 pi over 4. Okay. So let's see. Cotangent of pi over 4 is 1. And then cotangent of, this might be minus 1. Yeah, okay. Minus 1. Okay, now how many tick marks is, let's see. Well, we want to do actually pi over 3 divided by 4 is pi over 12. How many tick marks? Okay, well, 3 1/3 tick marks is a period. So if we would divide that by 4, about 0.83 tick marks is each of the quarter point, or each of the points here. So let's see. Around here, we're going to go to 1. And around here, well, no, let's see. This times 3, 2.5 tick marks, we're going to go to -1. And there we go. So like that. All right. And there we go. Okay, so here we've got a scaling up by a factor of 4 about the x-axis, and we're starting with the basic tangent, scaling up by a factor of 2, but then also a flipping about the x-axis. Okay, so we're going from period pi to period 4 pi. All right, we're dealing with tangent, so 1, 2, 3, 4, 5. We're going to go equidistant on both sides of the origin. Okay, now let's draw the vertical asymptotes. Okay, we're going to pass through the center, but now we're going to be flipped. So it's going to look like, it's going to be a shape like that. It's going to look like cotangent. Okay, but let's plug in, let's do y of pi is equal to, let's see, minus 2 tangent of pi over 4. We know tangent of pi over 4 is 1, so this is minus 2. And so y of minus pi is going to be 2. So, okay, let's do 5. Okay, so there's minus pi, and we're going to go up to 1, okay. And then there's pi, we're going to go down to 1, 2. Okay. All right. Okay, there we go. And that's the graph. Okay, so we're starting, the basic graph we're starting with is cotangent. It's scaled down about the x-axis by a factor of 2, so the period is going to go from pi to pi over 2. So let's see. Right, because we're not going minus pi over 2 to pi over 2, we're going from 0 to pi over 2 with cotangent. Okay, now let's draw the vertical asymptotes at the interval we're going to sketch. Okay, now we want to plot some reference points to help guide us with this. It's going to be stretched or shrunk about the y-axis by a factor of 2, and then it's going to be flipped, so it's going to look like tangent. It's going to look like that. Okay, so the middle, it's going to pass through the middle here. Then we want to evaluate, let's see, pi over 2 divided by 4 is, so we want to do y of pi over 8. So this is minus 1/2 cotangent 2 times pi over 8 is pi over 4. Okay, then we want to do y of, let's see, that would be 3 pi over 8. That's 3 pi over 4. So, okay, cotangent pi is 1, so minus 1/2. And then cotangent of 3 pi over 4 should be minus 1. Yeah, so this is positive 1/2. All right. So let's see, 2.5 divided by 2 is 1 1/4. So let's see, we'll still go from 5 to minus 5. So 1 1/4 and then minus 1/2, so here. And 2.5 plus 1 1/4, you're about here, so like that. Well, that's kind of hard to see. Let's do, so we'll do 2 to minus 2. Okay, so at 1 1/4, we're at negative 1/2, so 0.2, 0.4 right here. And then at, it's about 2 3/4 tick marks, or no, 3 3/4 tick marks, we're at there. So, like that. And there we go.